video is on chemical reactions and enzymes. We're going to look at what happens to chemical bonds during chemical reactions, how energy changes affect whether a chemical action is likely to occur or not, and the role that enzymes play in living things and what affects the function of those enzymes. So chemical reaction is a change of one set of chemicals into another set of chemicals. Elements or compounds that engage in a chemical reaction are known as reactants. They're the things that we start out with. They're on the left side of the chemical equation. Elements or compounds produced by chemical reaction are known as the products. They're what we end up with. They're on the right side of the chemical equation. So energy plays an important role in reaction. Chemical reactions that release energy are oftentimes occur spontaneously. Chemical reactions that absorb energy usually require a source of energy. You can see here we've got an energy absorbing reaction and an energy releasing reaction. All reactions, whether they absorb energy or release energy, need a certain amount of energy to start. So based on this, we know that energy releasing reactions are more likely to occur spontaneously. So the amount of energy needed to start the reaction is called the activation energy. You can see it's less so in the energy releasing reaction than the energy absorbing reaction. So a catalyst is something that speeds up a chemical reaction without being used up by the reaction. It's not a reactant or a product. Catalysts work by lowering the activation energy, the amount of energy needed to start the reaction. So paper will react with oxygen in the air. But we can speed that up by adding heat, by lighting the paper on fire. So enzymes are biological catalysts, and most enzymes are proteins, and the shape of the enzyme is important to its function. Enzymes lower activation energy and speed up chemical reactions in cells. The reactions that living things need to occur wouldn't occur fast enough without enzymes. So enzymes are really important. You can see in the graph here, with the enzyme, the activation energy is much lower than without. So the way enzymes work is they have an active site, and that active site fits with the substrate, the reactants in the reaction that they speed up. So a substrate is the reactant of an enzyme catalyzed reaction. The active site is where the substrate binds to the enzyme. The enzyme and substrate fit together by what we call the induced fit model, where the substrate changes shape slightly as it fits with the active site, and that weakens the bonds, and that's what lowers the activation energy. So we can see this here in our diagram. You've got carbon dioxide and water are going to react. The enzyme carbonic anhydrase is where the two reactants fit, forming the enzyme substrate complex. The substrates are converted into products, and then they are released, and the enzyme can be reused. So anything that can affect the structure of the active site can affect the activity of the enzyme. The two main things are pH and temperature. Both of those can change the shape of the protein or denature the protein. And when that happens, it no longer functions properly. Every enzyme, every protein has an optimal pH where it works best and an optimal temperature where it works best.